Austin, am I audible clearly?
Yes.
Okay, so today we are going to complete this chapter and do a lot of questions from NCERT as well as CE. So, Haloalkanes and haloarenes. Basically, we talked about the chemical properties and we didn't complete the electrophilic substitution reaction. Of only we did the part nucleophilic substitution reaction, in which we saw that nucleophilic substitution reaction is not so fast. It is very basically haloarenes are very less reactive towards nucleophilic substitution reaction. There are three regions in which one of them is phenylcation. Resonance was there, and also we can say is the difference in hybridization. So today we are going to complete this electrophilic substitution reaction. And this electrophilic substitution reaction is for haloarenes. Electrophilic substitution reaction. So from the name, you know that there will be an electrophile which will attack on the reactant. So please tell me, will you be able to draw the resonating structure of this? Let's say this is your X. You know this X will have lone pair. So will you be able to draw the resonating structure of all this? Write down the resonating structure. Will you be able to draw the structures? Mom.
I don't know, sir.
Okay, so this is see, this is your resonating structure I'm going to draw. First of all, whenever a single bond is connected with any group and that group has lone pair, then it will give electron. That means this group will act as plus R. That means donation. And whenever there is double bond and any group is there and there is lone pair, then it will attract electron. Double bond attract electron, single bond it will start giving. Is that clear? So
Yes.
see, this carbon is already making how many bonds? 4 bonds. Let me make it straight since I'm right-handed like this. Now you can see already this carbon is making 4 bonds. So this 2 bond will come and make a bond between X and this carbon. So this carbon have to move its electron to this place. So what will happen? You can see 2 electrons will move together. So there will be a negative charge. Now there is a double bond X, and since this X halogen has donated electron, so it will have positive charge. The rest part will be as it is. And you are going to do the same for this. Again, when you are going to move this, you have to move this electron to this position because it already making 4 bond. So you can see what will happen now. It's very easy. This is negative charge. Now this negative charge becomes the double bond and the rest part will be as it is. As it is. Okay. Now again, when it will move to this point, it will move to this point. Okay. Now you can see the negative charges move to this point. Now double bond comes here and the rest part is as it is. Now when you are going to move this, it will be like this. And then you can see double bond is there, double bond is there, double bond is there, and single bond you can see. Again, this will go to like this, and the lone pair as it is. So these are called canonical structure or resonating structure. Is that clear?
Yes, sir.
Okay, one more question before you are going to write. I want to ask, what do you think if this is your electrophile where I'm going to write E plus that represents electrophile. Everyone knows that what is electrophile, right? Both of you.
Yes.
Yes.
Electrophile is the one which is electron deficient compound. Okay, electron deficient compound. So what do you think out of these three? Out of these three, basically this and this will be same. So out of these two, you can take these two or these two. What do you think? This E plus electrophile will attack at which position? With respect to this position, you can see with respect to this position, you have this ortho, this is your meta, and this is your para. So you have three position: ortho, that is this position, this is meta, and this is para. Ortho, meta. On which position this electrophile E plus will attack? Ortho, meta, para. What do you think?
Ortho.
Only ortho? See, as you know that this is electrophile which is electron deficient, so it will attack at that position which is electron rich, and you can see the negative charge is at ortho and para only. So electrophile will attack at both two position. One is ortho and para. It doesn't want to go at or meta, because you can say there is no negative charge, there is no electron rich density center, you can say. Are you getting my point, both of you, Austin and Humam?
Yes.
Yes.
So that's why when we are going to study electrophilic substitution reaction, you will see the electrophile will attack at ortho and para position due to this negative charge on ortho and para, and this negative charge arises only due to this X, which has a nature of plus R, which has a nature of plus R. If it has a nature of minus R, then at ortho and para will have if it will have minus R nature, then ortho and para will have positive charge, and in that case this electrophile will have only one center left, that is meta, because At matter, resonance effect is zero. As you can see with this resonance, in this resonance, the negative or positive charge, whatever is the charge, that will be made only on the ortho and para, not on matter. So if you have E plus, that means electrophile, and the group attached to this benzene ring is electron withdrawing group. So the charge that will develop will be positive. That means electrophilic center is there. That means that ortho and para is basically your electron deficient center. So this E plus wants to go at that position where electron rich center is present, but it cannot go to ortho and para because it is already electrophilic center. So it has only one option left, that is matter. So in case of uh, R, it will go to matter only. Is that clear?
Yes.
Yes.
Okay, please do write this. This is very important, and let me know when you are done with this. Let me know when you are done with this.
Done, sir.
Both of you done with this?
Yes.
Okay. Now halogenes. Halogenes. This is your electrophilic substitution reaction. So in halogenation, basically we are going to do chlorination. This is your chlorobenzene, and you are going to react this with Cl2 in the presence of anhydride LCl2. So this reagent creates an electrophile, that is Cl plus. So you know that it has, this chlorobenzene has two nucleophilic centers, orthochloro, or you can see, and it is para. So basically we can write 1, 2 dichlorobenzene, and this is your 1, 4 dichlorobenzene. Can anyone tell me which one is more stable? This will be your major product. This will be your major product, and this will be your minor product, because there will be a steric hindrance between these two chlorine. So that's why. Please do write it. Are you done with this?
Yes, sir.
So if you are going for this nitration, this is your chlorobenzene, and you are going to treat this with concentrated H2SO4 and heat. So there will be, oh, not NO2, nitration is there. So HNO3 with concentrated HNO3. concentrated H2SO4. So NO2 plus will release and that will go at two places. At ortho and at para, in which para is more stable. This will have a name 1-chloro 2-nitro benzene. 1-chloro 2-nitro benzene, and this have a name 1-chloro 4-nitro benzene. Is that clear?
Yes.
Let me know when you are done with this.
Done, sir.
Okay, this is your nitration. After nitration, we have sulfonation. In the name, you can see whenever there will be SN, you are going to add. Here only concentrated H2SO4 needed. Chloro SO3. Now I'm going to write the name 2-chloro benzene sulfonic acid. Four chloro benzene sulfonic acid.
Done, sir.
Very good. Now see, the next one is Friedel-Crafts reaction, and you will see almost in every chapter of this organic chemistry. Friedel-Crafts reaction. No, this is of two type: Friedel-Crafts alkylation and Friedel-Crafts acylation. So if you are going to react this with chloromethyl or chloromethane on a hydride AlCl3, and see what will happen here. From here, you will get an electrophile, that is CH3 plus. So this CH3 plus will be added at ortho. Just write it. You can see this is basically when alkyl group added. So it is known as Friedel-Crafts alkylation. And if acyl group is added, I'll show you. This is your chlorine and this is your C double bond O CH3 at ortho. And at para. Its name is 2-chloroacetophenone. And this is 4-chloroacetophenone. Para will be the major. And since see the electrophile that is produced here will be CH3 C double bond O plus. And this is known as Friedel-Crafts acylase. Let me know when you are done with this.
Done, sir.
Austin.
Yes.
Now the third type of reaction, nucleophilic, electrophilic, and the third one is reaction with metals. The first one is Wood's fatigue reaction. Wood's fatigue reaction. In this three, like Wood's reaction, we used alkyl halide. In this Wood's fatigue reaction, we are going to use aryl halide as well as alkyl halide. So what will happen? This will be carrying in the presence of dry ether. And you can see this is your X, this is your sodium, and this is your X. 2NX will be eliminated as a byproduct, and this will be connected with each other. Just wait a minute. This is known as Wood's fatigue reaction. If you are going for fatigue reaction, very easy it is. In fatigue reaction, we take only haloarene. So you can see this is your X and this is your 2Na. So in the presence of dry ether, what will happen? Biphenyl will form. Plus 2NX. It is similar to the Lehd's reaction that is for alkyl halide, and this is for aryl halide. Let me know when you're done with this.
Done, sir.
Austin, you are also done with this.
Yes.
Let's start doing the question. Are you done with this? Very good. I'm just going to take it in this one. SN2 mechanism. This will be faster. In this one, this is 3 degree, this is 2 degrees, so this will be faster. Both has 1 degree, but this will be faster because this CS3 will be a steric hindrance. So in this way, both of you got the right answer.
Yes.
Please do this. Very easy it is. Okay, both of you. You can see in the SN1, this will be the first because it is 3 degree. This is your 2 degree. This will be the first because this is 2 degree and this is 1 degree. Very easy. The next question is regarding the reaction, which is very good. Series of reaction is there. Please do it. You need to calculate A, B, C, D, E. A, B, C, D, unit E, R, and R. Any answer? Austin and Humam, any answer? Okay, I'm going to explain. Very easy it is. First of all, when it is going to read, this is for Grignard. So A will be MGBR, this one. This is your A. After this, if you are going to react this with H2O, H2O has two parts, H plus and OH minus. And this is positive and this carbon is negative. So this H plus will directly go here and it becomes cyclohexane and the byproduct is your MgOHBr. MgOHBr. So this is your B. Okay, now come to the this one. Which is RBr. If you're going to react this with alkyl halide with magnesium, what you will get? Just wait a minute. What you will get in the presence of dry ether, you will basically get C, and C if you are going to react this with D2O. D2O is D is isotopes of hydrogen, deuterium. So you are getting CH3, CH, D, CH3. So basically, what is your C? C is basically CH3, CH, Mg will be there, and CH3 is there. That means here R is your CH3 and CH, Br is there, and then your CH, CH3. So R is your this. You can see. That's why when magnesium react with this, it will take place of this MgBr. It will be MgBr like this, and from this to this and this to this, you can easily get. Is that clear, both of you?
So we repeat.
See, if you are going to react this CH3, CH, CH3Br, so in the presence of dry ether, this is what you will get, MgBr, because wherever Br is, Mg will come in contact with carbon. And when you are going to react this with D2O, again, D2O will have two part, D plus OD minus. In the same way, like H2O has two part, H plus and OH minus. This has positive, this has negative. So this will go to this and you will get this. Is that
Yes.
clear?
Yes.
Please do write up to this, then we are going to discuss about the next sheets. Let me know when you are done. Are you done with this?
Yes.
Okay. Now see if you're going to react this with sodium ether, that means it will be doubled. You just need to break this bond and take chlorine. So that means this R1 will be like this. X is there, X you can see, X will be there like this, and then CH3, then CH3, then CH3. It doubles now, that's why this part is your R1, R1. And if you are going to react this with Mg, what will form? It will be like this, CH3, 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 and magnesium will come with contact with carbon directly, X will be there. And after this, you can see if you are going to react this with H2O, that means H plus OH minus, H plus and OH minus. So there will be positive sign, there will be negative sign. So it will directly go to this and you will get like this. The structure will be like this, CH3, and then CH3 is here, and then CH3 is here. Okay. So it's something like CH3, CH3, and CH3, 2-methyl propane. Please do write. Are you done with this?
Yes, sir.
So the next question is about conversion, and you are going to convert one bromo propane to two bromo propane. Let me know when you are done with this. Very easy question. Austin, are you done with this?
Yes.
Humam, what about you?
Yes, sir.
It's very easy. You can see one bromopropane, that means CH3, CH2, CH2Br. But you need two bromopropane. So first I'm going to react this with alcoholic KOH and heat. Then what will happen? This bromine and one hydrogen will be lost, removed, eliminated, and there will be double bond between us. And since we need two bromopropane, we are going to react this with HBr in the presence of peroxide so that no. Marconico, we are going to follow HBr so that this Br will go to this and we will get this. Is that clear?
Yes.
Both of you did it correctly. Now there is one more thing that you need to do in this chapter. And the last of the chapter, you will see there are polyhalogens compounds. Polyhalogen compounds, which is very important, their uses and their formulas. So you are going to go through this in the next class. I will give some questions and test it. And also, which chapter is going on in your school, both of you, Austin and Mark?
We have done only until here.
What did you say?
We have done only until here. We haven't started any other chapter.
Okay, Humam, what about you?